Hi, we would like to learn shear force and bending moment diagram. Shear force and bending moment diagram is one of the most important topics of solid mechanics. So let's begin with the definition of shear force. The shear force at a given cross section of a beam is defined as the algebraic sum of unbalanced transverse forces acting to the left or to the right of the given cross section of the beam. So to understand shear force, let's have an example of a cantilever beam. So we have a cantilever beam AE having points A, B, C, D, E. The end E of the beam is fixed and there are transverse forces F1, F2, F3 and F4 acting on the beam. So if you want to find the shear forces acting at various points of the beam, first we should draw the free body diagram of the beam. So here we have a cantilever beam having points A, B, C, D, E, and the forces are acting F1, F2, F3, F4. Now, since this point E is fixed, therefore there will be a support reaction acting at point E. So Re is the support reaction acting at point E. So the value of support reaction Re can be found by considering the condition of equilibrium. We can find out the value of Re as F3 plus F1 minus F4 minus F2. So we can easily calculate the value of support reaction Re for a cantilever beam. Now since it is a cantilever beam, point E is a fix, so there will be ME acting at point E. So we got all the forces acting on the beam as well as support reaction as well as reaction moment acting on the beam. Now we are interested to find the shear forces acting at various points of the beam. For the sake of simplicity, we are only going to consider point A, B, C and D, and we will find out shear forces acting at these 4 points only. So if you want to find the shear force at point A, so as far as definition is concerned, the shear force at any particular section of the beam is the algebraic sum of unbalanced transverse forces acting towards left or towards right of this particular section. So if I want to find the shear force at section A, we shall consider a plane at point A. So now we shall find all the unbalanced forces acting towards left of this particular plane or towards right of this particular plane. Since there are no transverse forces acting towards left of this particular plane, so we can say that the shear force at particular point is A is 0. If you consider the right hand side of this particular plane also, beam is in equilibrium condition, so summation of all these transverse forces is going to be 0. So now we have no shear force acting at point A. Now we would like to find the shear force at point B. So we shall consider a transverse plane at point B and we'll find out the unbalanced transverse forces acting to the left of this particular plane or to the right of this particular plane. So we are considering left hand side of this particular plane. So the unbalanced transverse force we can see here is only F4 and it is acting upward. So there is sign convention for the shear forces. So sign convention is like this. So if you have a plane and if a shear force is acting in the upward direction to the left of this particular plane, then it is taken as positive. And if you go to the right of this particular plane, then the downward shear forces are taken as positive. Similarly, if I consider the plane again, so again, if there is a downward shear force acting to the left of this particular plane, it is taken as negative. So upward shear force to the left of the plane is taken as positive and downward shear force to the left of the plane is taken as negative. Similarly, the upward shear force to the right of the plane is taken as negative. So downward to the right is taken as positive and upward to the right is taken as negative. So now by this sign convention, it is quite clear that this F4 is acting upward direction and upward is taken as positive if it is towards the left of this particular plane. So it is going to be positive F4 here. Now we would like to find the shear force at point C. If we want to find the shear force at point C, we shall consider a transverse plane at point C and we are going to consider all the unbalanced transverse forces acting to the left of this particular plane. So the upward is positive if you are taking to the left of the plane, and downward to the left is taken as negative by the sign convention. So this is going to be positive and this is going to be negative. So I'll write down that. So we have plus F4 and we have minus F3. This is F3 minus downward. So minus F3. So we have found the shear force acting at section C. Now we'd like to find out the shear force acting at point D. We shall consider transverse plane at point D and we'll take all unbalanced transverse forces acting to the left of this particular plane. So upward F4, upward F2 and downward F3. So upward are taken as positive while downward are taken as negative. So we can write down here plus F4 minus F3 and then again F2 is upward, so plus F2. So like this we can find out the shear forces at various points such as A, B, C and D. We are not finding out shear force right now at point E just for the sake of understanding. We shall do it later on when we take actual example.